Hello everybody, this is Mr. Kusaj and we are back with the next lesson, 8-3. Don't forget the date here. The title is Dot Product and Vector Projection. Let's deal with dot product first. Dot product is a skill that you can do with two vectors, and then we'll use a dot product to find and do other things with it. But how do you do the dot product? Well, it has something to do with multiplying, right? So for any two vectors, if you want the dot product, first of all, the notation is a dark spot like that, right? A dark circle like that. So this says A dot B, right? What do? Well, you multiply the first components, then multiply the second ones for both of them, right? Get those answers and you're done? No, then you add them. So you're going to end up with a numerical value. Okay? Orthogonal vectors, orthogonal vectors are perpendicular vectors. So how are you supposed to know they're perpendicular? You don't see the picture. But if their dot product comes out to 0, then you know the vectors are perpendicular, or as we call them, orthogonal vectors, okay? So let's practice doing the dot product. So let's do one at a time. If U is 2, 5, and let me put it up a little bit. If U is 2, 5, and V is 8, 4, then what is U dot V? Well, we multiply 2 times 8 and 5 times 4, right? And then we add those products and we're done. So the dot product of U and V is 36. What is the dot product of U and V over here on the right? Well, this is U, this is V. So it'd be 3 times -4, 6 times 2, and then we add those numbers. And, oh wow, look. It comes out to 0. So without the benefit of seeing the vectors, right, I know that they make a 90-degree angle. They're orthogonal vectors. In fact, I wrote it down here. Orthogonal vectors, okay, because it came out to 0. Okay, properties. Properties, meaning what else can you do with that skill? Can you do anything? Well, yeah. You can if you flip them over, you get the same answer. So you're right. You can do in either order. You can do them in either order. You can do first times the second or the second times the first. It doesn't matter. Okay. What else can you do? Well, if you have a vector and the sum of two other vectors, and you want to find the dot product, it's just like distributing. It's U dot V, do all of that, and then U dot W, do all of that, and then, forgot the dot here. And then, right, and then you add those two answers. What if there's just a number on the outside of the dot product? Well, then you multiply it into only one of them, right? Because this is like a multiplication, right? It's that you don't do distributive here. So you can multiply it to the first, or you can multiply it to the second. It doesn't matter. And then do the dot product after that. So it could be KU dot V, or it could be KV dot U, right? And this last one on the bottom here, this last one says that if you do dot product of a vector and itself, right, then you're going to get the magnitude, but it's going to be the magnitude squared, right? We've looked for the magnitude of a vector before, but this is another way of doing it. Okay, it comes out to the same thing. So another way to look at this is, right, if I square root both sides, right? Don't I get this? So if somebody asks for the vector, if somebody asks for the vector, for the magnitude of a vector, maybe you can do square root of the vector dot product of itself, right? Okay, we're going to use, I put a star here because we're going to use this in other problems. Okay, so basically, I put it in a box. This is how a dot product works. When you're asked to do a dot product, this is how it works. All right. So, looking at that last property, right, we can use the dot product to find the magnitude. Well, what is the magnitude of this? Well, if you remember, it was like, if this was the first part, second part, first part squared plus second part squared and then square root, well, yeah, that's what it comes out to, if you think about it. So, from the property we just had, magnitude squared is equal to A dot A, right? Square root both sides. And how do we do A dot A? Well, I guess it's -5 times -5, 12 times 12, and then add the 2. But isn't -5 times -5 -5 squared plus 12 squared? So you can jump ahead and get the answer. Square root of 169 is a whole number, so we write the whole number. I found the magnitude of A. Okay? So I used a dot product to find the magnitude of a vector. The angle between two vectors, any two vectors, right? Any two vectors, if you put them together, they form an angle. Well, I have a formula that tells me what the angle will be, and that formula includes the dot product. So you have to know how to do the dot product to do this part. See? We're taking the dot product and using it somewhere else now. So here are two vectors. What is this angle? Well, cosine of the angle is equal to A dot B, and then the magnitude of A times the magnitude of B. Right? Well, we know how to do dot. We just did it. We know how to do magnitudes. We just did those. So this is cosine of the angle. Well, how do you get the angle? Well, if you remember from previous chapters, it's the inverse. So if you want the angle, it's the inverse cosine. Let me pull it up. It's the inverse cosine of this over this. Okay, so let's practice. I put this in a box, so let's practice this. I want to find the angle between two vectors. Here are two vectors. What is the angle between U and V? Well, going back to the formula in the box, right? Cosine of the angle is equal to U dot V. So I got to do that. And then I got to multiply the two magnitudes. So I got to find the magnitude of U, the magnitude of V, and multiply those for the bottom number. Okay? So let's do the top first. 6 times -4, 2 times 3, there it is, and then add the products. What's the magnitude of U? Well, it's, remember how we did it? It's 6 squared, 2 squared, add them, and then square root. Now let's do V. -4 squared, 3 squared, add them, square root. There it is. So this is the magnitude of U, magnitude of V. And this is the product of UV. The dot product of UV. Okay? Calculator in your head, whatever. You get this. Right? But this is cosine of the angle. We want the angle. I simplified it some more. I want the angle, so the angle is the inverse cosine of this. So you enter in the calculator exactly the way you see it here, and it'll give you the answer, which is 124.7. So these two vectors, if I were to draw them, the angle will be 124.7, which is way more than 90, but less than 80. Hey, you know what? Just for the heck of it, let's draw them. So let's start here. U would be 6 across, 2 up, right? You don't have to do this, just watch. 6 across, 1, 2, 3, 4, 5, 6, 1, 2 up. So there's U. Where's V? -4 to the left, 1, 2, 3, 4, 3 down, 1, 1, 2, 3. There it is. There's V. Hey, look at that. Exactly what I said. More than 90 but less than 180. That angle is 124.7, right? But I did it without the benefit of any diagram or pictures. Okay, so let me leave you with some try problems, exactly what we did in the notes. So here's the first one. Simply find the dot product of U and V. Just do that on your own. Can you do it without looking back? Sure you can. Here, find the angle between these two vectors, right? This one, maybe you forgot. Look back at the box where we wrote down the formula for finding the angle. Okay? That's it for part 1. Let's move on to part 2. All right? See you in part 2. Bye.